Hello there, welcome to this video. Today we're going to talk about the law of cosines. The law of cosines is another tool in your tool belt to help you solve for missing sides and angles of non-right triangles. Now again, if you have a right triangle, you're going to go ahead and use the SOHCAHTOA tool. But what if it's not a right triangle? When do you use law of sines versus law of cosines? Today we'll discuss how to find missing sides and angles of non-right triangles using the law of cosines. All right, let's go ahead and look here at our prior knowledge. And what we want to do is choose an order that represents the angle from greatest to least. But I don't have any information about my angles. I only have information about sides. So what I want you to remember or think about kind of intuitively, now my angle measure, how big my angle is, that's going to determine how big the side opposite is. So if I have the largest side, that's going to correspond to the largest angle. So angle A would be our largest angle, so A and D are going to go out the window, and then our next largest side, it looks like 8.4, well that's opposite angle C, so angle C is going to be our next biggest angle, and then our smallest itty bitty angle is angle B, that's our smallest. Okay, so option B there was our final answer. Okay, so we're going to use that idea today to introduce the law of cosines. Now, in order to use the law of sines, what you have to have is you have to have a relationship. You have to have an angle and a side opposite, or a way to find that relationship. For triangles where you have all sides, side, 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 or if you have two sides with an angle in between, known as side, angle, side, the law of sines cannot be used. In these situations, we have to go ahead and use the law of cosines. So, what is the law of cosines? And I know this is going to look a lot like gibberish here. And really, you only need to focus on one of these. But here is the formula for the law of cosines. Okay, so what it is, a squared is equal to b squared plus c squared minus 2bc times cosine of A. Okay, now I want you to focus on the structure here. The structure a squared is equal to b squared plus c squared. That kind of looks like Pythagorean theorem. So that's one way to look at it. And then it is minus 2bc, minus 2bc. Well, hey, isn't that the side values that we use there? Times cosine of the angle, times cosine of angle A. Well, that's the side that we're solving for. So there is a pattern there that if you can go ahead and memorize it, and then again, this applies for any of the other sides. If we can just go ahead and kind of switch these around, okay? So let's go ahead and look at an example. What I would recommend doing is I would recommend at least writing one of these on a flashcard and quizzing yourself, trying to memorize. Okay, so that way you can help kind of commit that to memory. Now, what if you don't know where to go, if you're lost? Here is your Google Maps GPS. What do I do? How do I solve? If you are given all sides, what you need to do is you need to find the largest angle first. This determines whether the triangle is acute or obtuse. It's an obtuse triangle, right, if it has an angle bigger than 90. Secondly, you're going to go ahead and use the law of cosines in order to find the second largest angle. Okay, and then once you have that, you can go ahead and find the triangle sum theorem just by subtracting those two angles from the third. What if you have side, angle, side? Well, when side, angle, side is known, you're going to go ahead and find the side opposite the known angle. And then you're going to go ahead and find the largest unknown angle measure using the law of cosines. Once you have that angle, you can go ahead and find the third by doing triangle sum theorem. So again, here are just the step approaches, and I'll refer back to these as we go ahead and look at solving these today. Okay, here is our first example. Solve the triangle. Round side measures to the nearest tenth and angle measures to the nearest degree. What I like to do right away is I like to go ahead and make a list here of all the information that I do have or don't have. So let's say here, okay, measurement of angle A, I don't have it. Side A, that's 7. Okay, measurement of angle B, 100 degrees, and big B, don't have it. Okay, next, measurement of angle C, don't have it, but big C is 5. Okay, so I first want to point out why we cannot use law of sines. That's everyone's favorite, sometimes even more so than SOHCAHTOA. I cannot use law of sines because I don't have a relationship between an angle and its corresponding opposite side. So in this situation, given two sides in an angle, we're going to go ahead and use the law of cosines in order to go ahead and find this. Okay, and since I already have this angle, I'm going to go ahead and use this angle. I'm going to find the side opposite. So that's what I'm going to do first. I'm going to go ahead and find not big B. Did I seriously label these big B's? This is little b. What am I thinking? This is little a. And then that's little c. Believe it. It's little c. Okay, so we're gonna find b here. Okay? So I'm gonna go ahead and use the law of cosines. Law of cosines. So b squared is going to be equal to, I'm gonna add up my other two sides, a squared plus c squared. Now I'm gonna subtract 2 times a times c, whatever sides I already used on this side, and I'm going to multiply this times cosine of b, whatever that value is, okay? So b squared is equal to, okay, a squared, that's 7 squared plus 5 squared minus 2 times 7 times 5 times cosine of 100. Now I can go ahead and simplify this too, simplify my life. I'm just going to go ahead and I'm going to take all of this and I'm going to take the square root of all of it. 7 squared plus 5 squared minus 2 times 35, but I guess I can just leave it as is, 7 times 5, cosine of 100. Okay, and we're going to plug this into our calculator. Okay, so here's calculator. Let's control. Is it not letting me? Do I gotta do? Add a calculator. Okay. Boop. All right. So we want 7 squared plus 5 squared minus 2 times 5 times 7 times cosine, and cosines here, of 100. And I'm going to switch, make sure I'm in degrees because I'm working with degrees. And then we'll go ahead and round that. It looks like we get 9.3. 9.3. Okay. 9.3. Good. Got that. Okay, so B is 9.3. All right, what we're going to do next, we are going to go ahead and find our next angle measure. Now, since the largest angle was given, and I know that this was the largest angle because it's 100 degrees, it's the biggest angle, I can use law of sines, and this is important, this is very important. I can use law of sines when I am finding an acute angle. Law of sines does not give me angle measures that are bigger than 90 degrees, okay? Law of cosines will return a value bigger than 90. It just has to do with the range of the inverses. But I can do either option here. So a lot of you will prefer to do law of sines. This is 100. If it's not obtuse, then you're going to have to use law of cosines. This is a law of cosines lesson, so I'm going to go ahead and I think I want to do a law of cosines. So you know what? That's what I'm going to do. Let's go ahead and do another law of cosines. So what I'm going to do is I'm going to find measurement here of angle A. We're going to find the measurement here of angle A. Okay, so how do I find the measurement of angle A? Well, I'm going to go ahead and use the formula that uses A. Okay, so that's going to be A squared is equal to B squared plus C squared minus 2BC cosine of A. And I'm using this formula. Because I want to go ahead and isolate cosine of A. So let me go ahead and before I plug everything in, I'm going to isolate cosine of A. I'm going to go ahead and subtract B squared and C squared. So subtract B squared, subtract C squared, and this gives us A squared minus B squared minus C squared is equal to negative 2BC cosine of A. Okay, and I want to isolate my cosine of A, so I'm going to go ahead and divide by negative 2BC, divide by negative 2BC. Okay, and we get cosine of A is equal to A squared minus B squared minus C squared all over negative 2BC. Okay, and then therefore this implies that A is equal to cosine inverse of these values. A squared minus B squared minus C squared all over negative 2BC. Okay. All right. This is important. Make sure you write this formula down on your paper. That's important because that when we solve for angles, that pops up a lot. But I'm going to go ahead and I'm just going to plug in now these values. Okay, I'm going to plug in these values. So A is equal to cosine inverse of A squared. Again, A in this case, let me find out what A was. A was 7. 7 squared minus B squared, 9.3 squared minus 5 squared. Okay, all over negative 2BC, negative 9.3 times 5. Okay, so we can go to our calculator and plug this in. Okay, so I want cosine inverse of, so it was 7 squared minus 9.3 squared minus 5 squared all over negative 2 9.3 times 5. Okay, and we get 47.7, which is about 48 degrees. So approximately 48 degrees. Okay? All right. And if that angle is 48 degrees, then I know that its complement, or actually not its complement. When added to 100 degrees, it's going to give me 148. And then I want 180, so just by simple subtraction, right, 180 minus 148 is going to give us 32 degrees, okay? And there you have it. All right. Okay, here is a practice problem. Please go ahead and try this one. On this one, it helps. I don't know why they're mean and they didn't give a triangle. Let me go ahead and help draw a triangle, and we'll just call it A, B, C. Doesn't matter where they are, where the information is. It's going to be the same. Here, this side is 23. Side C is 18, and angle A is 173 degrees. Okay, so go ahead, use law of cosines in order. First, just try law of cosines. I want you to find side A using law of cosine. Okay, unpause me here in a second, and then I'll show you how to find that value. All right, hopefully you went ahead and did that. Here is what you should have gotten. Remember, law of cosines, a squared equals b squared plus c squared minus 2bc cosine of a. So given all of this information, looks like we have 23 squared plus 18 squared minus 2 times 18 times 23. I might have flipped those. Times cosine of 173. And then you're going to square root all of that to give you side A. Okay? And hopefully if you did that, you got 41 degrees. You should have gotten 41 degrees for that. It's not 41 degrees. That would be 40.9. That's a side. 40.9. And that makes sense. That's definitely the largest side because look at how big that angle is, 173 degrees. Okay, now that I've done that, go ahead, pause me again, find the rest of the information using any tool you want. You don't have to do law of cosines again, but try the rest of that. All right, hopefully you pause that and tried it. Here is the solution. You should have gotten these values. You could have done law of cosines again in order to find an angle measure, or you could have used law of sines, and then in order to find a measurement of angle C, you just do triangle sum theorem. All right. Okay. All right, here is the next example, and here again, they don't give us a triangle, so let's go ahead and draw a triangle ABC. They say A is 10.5, B is 6.3, and C is 12. What do? How do I go ahead and find all of this information? Now what you're going to do is you're going to target the largest angle. You want the largest angle. You have to use law of cosines. Get the biggest angle out of the way. That's going to involve C. I'm using law of cosines. I want cosine of C. So the formula I'm going to use is C squared is equal to A squared plus B squared minus 2AB. Got to get those on the same side. Times cosine of C. Okay? Now what I'm going to do, I'm just going to go ahead and rearrange this formula in order to isolate C. I'm going to move the A squared and the B squared to the other side. Okay, that gives us this. And then I'm going to go ahead and divide everything by negative 2AB. Negative 2AB, cosine of C. And then I'm going to take the inverse, cosine inverse of C squared minus A squared minus B squared all over negative 2AB. Okay? So let's go ahead and plug those values into our calculator here. Okay, so control, we want cosine inverse. Okay, and I want C squared, which is 12. Oh yeah, I never plugged these values in. My bad, guys. Cosine inverse of 12 squared minus A squared, which is 10.5 squared, minus B squared, which is 6.3, all over negative 2 times 10.5 times 6.3. Okay, if you can see that behind me, there we go. So let's plug this in, 12 squared minus 10.5 squared. Gotta make sure I get out of that exponent. Minus 10.5 squared minus 6.3 squared. Okay, over negative 2 times 10.5 times 6.3. Okay, and this gives us 87 degrees. 87 degrees. 87 degrees. 87. Okay, so I found C. Now what I'm going to do, I'm going to go ahead and utilize everyone's favorite. I'm going to use law of sines. So I'm going to use sine of 87 over 12 is equal to sine of A, which is equal to 10.5. So now I'm going to go ahead, I'm going to solve for A. I have a relationship. I can utilize law of sines, okay? So 12 sine of A is equal to 10.5 sine of 87. And then I'm going to go ahead and divide both sides by 12. So we get sine of A is equal to 10.5 sine of 87 over 12. And then take the inverse of that. A is equal to sine inverse of 10.5 sine of 87 over 12. 87 over 12. Okay, so let's plug this in, see what we get. All right, sine inverse of 10.5 sine of 87 over 12. And we get 61 degrees equals 61 degrees. Okay, 61. All right, and then in order to find angle measure B, measurement of angle B, that's going to be equal to 180 minus 87 minus 61. Okay, so this is what, minus 148. So is that 32? 32 degrees. And yes, 32 degrees. Okay, cool. All right, so that's how you do it by solving for the angle first. You always want to target the largest angle. All right, here is a practice problem for you. Please go ahead, pause the video, try this one from bottom to top, and see what you get. Okay, here is the solution. You should have gotten these values. Measurement of angle A is 56. Measurement of angle B. Angle B is what you should have found first, okay? Measurement of angle C, 43 degrees. All right, and our closure. What kind of angle measures can law of cosines find? What kind of angle measures can law of sines find? It's very important that you realize this. The law of cosines, it can be used to find both acute and obtuse angle measures. Law of sines can only find acute angle measures. So keep that in mind when you're using these. Law of sines will only return angles below 90 degrees. All right, that's the law of cosines. Hopefully gave you a couple different examples where you would see it. I'll catch you in the next video. See ya.